Hello again. As you know, I am Eli, the computer guy. Today we're doing an introduction to the Arduino. So now in this modern world, people are talking about IoT devices a lot, basically Internet of Things. The idea that most of your devices that you're going to have are going to be intelligent and that they're going to be able to connect to the internet. And so Arduino boards are one of the ways that you can go about building your own IoT devices. Now, it is important to understand what an Arduino is. So, whenever we talk about IoT, people in the same sentence will many times talk about both Arduino and Raspberry Pi. And so, a lot of people get confused and they think one is the other, and basically they're the same thing. But it's important to understand that the Arduino is the Arduino and the Raspberry Pi is a Raspberry Pi. So, basically, when you're dealing with a Raspberry Pi, essentially what you're dealing with is a very inexpensive computer. So it will have a Linux operating system on it. It will have the normal RAM that you're used to, the normal type of CPU that you're used to. It will just be incredibly small and incredibly inexpensive. So you'll load an operating system on there, and then when you code, you'll actually be coding to the operating system. What's important to understand with the Arduino is that this is a microcontroller platform. So is it a computer? Well, yeah, kind of, sort of. Along the lines of how your thermostat in your house is a computer. As in, you can program it so that when certain inputs come in, it will then perform certain actions. That does not mean you're going to put a MySQL database on it, and it sure as hell doesn't mean that you're going to be watching any movies off of it. But basically, that's what you do with a microcontroller platform, such as the Arduino, is you connect sensors to the Arduino platform. It will then have code inside, and then depending on what conditions happen, it will then trigger events. So with an Arduino, you can have this connect to temperature sensors, you can have it connect to light sensors, you can have it connect to distance sensors, all kinds of different stuff. And then you can also have it connect to things like LED lights. You can have it connect to motors. You can have it connect to servo motors. And you can have it connect to many other electronic devices in order to create physical actions. So again, think about it as a more complex version of your thermostat. So think about your thermostat. You program your thermostat. So when it gets to 80 degrees, the air conditioner turns on. When it gets to 65 degrees, the heat turns on. Right? So basically, this is a more complicated version of that. To be clear, you're not installing MySQL on this thing. A lot of people get a little confused on that. One of the things with the Arduino that makes it very special is it's an open source hardware device. What that means is anybody can manufacture Arduino hardware, and they can also modify Arduino hardware. So whenever you're dealing with normal computer devices, certain companies build certain products. The thing is, whenever you're dealing with Arduino, there are some Arduino manufactured products. So they're actually manufactured by Arduino. But there are other things such as, like with this. So this is an official Arduino board created by Arduino. And this is a mega board that's actually created by SaneSmart. So they're compatible boards. They use the same architecture. This one is manufactured by SaneSmart. This one is manufactured by Arduino. Now with this, why this can be very valuable is that people can use these Arduino boards in order to create fully functional devices. So you can create robots, you can create sensors, all of those kinds of things, and then you can implement them as they are. So you can actually build your product and then do with it what you will. But the other thing that the Arduino is used for, and this is important to understand, is a lot of people use the Arduino for prototyping. So all the components on the Arduino board and on shields and on modules are basically off-the-shelf products that are simply soldered together. So what a lot of people do with prototyping is they will create a device based off of the Arduino board. They will prove that that device works, and then what they'll do is they'll go through and they'll actually design an electronic device with the components that they're using off of the Arduino without all of the other components. So that's where a lot of times you'll hear about prototyping, where essentially people will they'll put the whole device together. They'll prove that the device works, and then what they'll do is they'll go off and get schematics drawn up to actually create that specific device without all of the extra components. So this is basically what we're talking about when we're talking about the Arduino board. So when we're talking about the Arduino board, we're talking about the board itself. So this is the microcontroller board. We're going to be talking about shields today. We're going to be talking about modules today. We're going to be talking about a couple of the other electronic components you can use with the Arduino, and we're going to be talking a little bit about the IDE, so you get an idea of the entire Arduino platform and get a better idea of how this is actually used in the real world. Now, before we can get to the fun stuff, we got to talk about the sponsors, because the sponsors are the ones that pay the bills. So we have Cumulus Networks. Cumulus Networks wants to know your thoughts on web-scale networking. Fill out their survey, and you can win an Apple Watch at cumulusnetworks.com/Eli. Geist builds and delivers rack PDUs ultra quick in as few as 5 days for standard units. Made in America, #60PDUs, geistglobal.com. Veeam, free backup for PCs, VMs, and Linux, all at veeam.com. Dev Mountain is a 12-week web development, iOS, and UX design bootcamp until you get a full-time job in the industry. Learn to code at devmountain.com. INE specializes in network training with hands-on labs, on-site bootcamps, and focused on delivering the best in online networking courses at INE.com. Plixer with Scrutinizer and Flow Data. Users can determine what traffic is on network, who is originating traffic, and who's receiving it. Plixer.com. And finally, Gilware Data Recovery. Gilware partners with IT professionals to offer their end users data recovery services and digital forensics. Find out more at Gilware.com. As I always say, don't really care if you thumb up, thumb down, leave a comment, or subscribe, but if you click on those sponsor links below, this is what helps pay for Silicon Discourse and videos like this and everything else that I do. Now, the first thing that we have to talk about is the Arduino board. So this is the core of your finished Arduino device. This is where you're going to upload your code to. So you're going to be writing code in the Arduino IDE, and then you upload it onto this. This is where the main power for your system goes into. This is where all your sensors connect to, your modules connect to, your shields connect to. This is basically the main computing component of your Arduino. Now, when you're looking at this, one of the things that you do have to realize is that there are many different versions of the Arduino board. As we talked about before, the Arduino is an open source hardware project, which means anybody can take the schematics and they can design their own boards based on what they think individual people want. The good part about that is that there's 1,000 different types of Arduino boards out there. The bad part about that is there's 1,000 different types of Arduino boards out there. So different Arduino boards have different components attached to them. They may even have different USB connections. Basically, people take the standard schematics for an Arduino board, and then they can add to it or they can subtract to it as they see fit. Why this is important for you to understand is because when you're going out there to design your project or to build your project, what you're going to need to look at is, does your Arduino board support all of the things that you need it to do? So does it need to be able to connect to Wi-Fi? Does it need to have a specific type of power consumption? Does it need to have a specific type of form factor? Are there additional types of sensors that need to be connected to it? Not only that, but obviously whenever you buy any kind of branded component, it is going to be the most expensive. So when you're looking at this, so this is an actual Arduino board built by Arduino. This is the most expensive version of Arduino board. On the other hand, if you get an Arduino board that's been created by another company, such as SaneSmart, you may be able to save half the price. I think a normal Arduino board goes for about $25, whereas an imitation, or just a different manufacturer's type of Arduino board, you sometimes can get for $10. One of the things you have to be thinking about is this may have a higher quality than the cheaper version, and these are all the types of things that you have to weigh out. Again, there's no good. I'm not telling you have to buy Arduino branded boards versus another type of branded board. You just have to think, okay, this is probably going to be the most solid, the highest quality version, but it's going to cost you $25 per board. This, you may get a couple more DOA on arrival, but on the other hand, you may be able to buy them for $10 a piece. Now, if you look at these two, so this is, again, manufactured by Arduino. This is by a company called SaneSmart. You can see the differences in different types of boards. So this is the Arduino Uno, it's called. So this is the main standard board that most people start out with, and this is a mega board. And so the difference here is this allows for many more sensors to be connected to the board. I think this allows for something like up to 50 sensors to be connected to one Arduino board, where this doesn't allow for so many. Now, if we go over to the computer, we can start to get an idea of just how many different types of Arduino boards are out there. So this is the Arduino Uno release 3. As you can see, it's like $25 here at Adafruit. And if we go down, we can just look at all the different versions. There's a Mega 2560, which obviously is a lot bigger. There's an Uno Ethernet. So if you look at this, you can see that the Ethernet port is actually built right onto it if you wanted that type of thing. Mega with Ethernet. Then they have micro ones. They have incredibly small ones. Again, remember, they don't have to be manufactured in all the same way. So if you need something that's very, very small that may only need a couple of sensors attached to it, maybe you want a tiny one. And if you go down, you can just see there are so many different Arduino boards. And so this is an important thing, is once you actually start building products for customers or clients or for your boss, it's important that you find the best Arduino board. What you may find out is that when you design your initial product, you use a number of different shields in order to accomplish a task. So you put on, let's say, a Wi-Fi shield. We'll talk about shields in a minute. And then what you'll find out when you go to actually build 5 or 10 or 50 of the exact same devices is that you can buy an Arduino board that has the Wi-Fi component already built in. And so that will save you money. That will save you for energy consumption. That will save you for size and all of that kind of stuff. So the big thing to understand about Arduino boards is, although you'll be starting with the basic Arduino Uno for your initial projects, when you actually go out there to start deploying things in the real world, you will see that there are just a crap ton of options. So it's very important when you go out to buy Arduino boards for your projects, you really think about what you need and what board will really fit those requirements. Now, whenever you hear about Arduino boards, one of the things you will also hear about are shields. And so what shields are components that you can connect directly to your Arduino board in order to add functionality to the Arduino. So something like this is a sensor shield. So this allows for just a tremendous number of sensors to be able to be added to a normal Arduino board. And so what you're able to do is you are able to line up the pins on the Arduino board and the shield and be able to connect them together so that it becomes one device. So it's a kind of sort of like an electronics version of Legos. So this can be very useful for being able to add a lot of functionality, because if you look at a normal Arduino board, when you look at it, it's only got a certain number of pins and it only has a little bit of functionality. So if you want to be able to add functionality to an Arduino board, you use shields. So this is a sensor shield. So this allows you to add a lot of additional sensors. This right here is a motor or a servo shield. So if you want to be able to control motors or servos from your Arduino, this is an easy way to do it. They also have GPS shields. So if you want to be able to track the location of your Arduino device and actually be able to get our GPS signals, you can get a shield that will go on top of the Arduino. You can get Wi-Fi shields. You can get battery shields. They have shields that actually have batteries in there. There's just a tremendous number of shields. The other nice thing with shields is that they are also, many of them are stackable. So such as this is the motor servo shield. So what I could do here is I could connect this onto the board as such, and so now this gives me the ability to add motors and servos. And then if I'm going to have motors and servos, I probably need more sensors to be able to tell what the motors and servos what they need to do. And then on top of that, you're able to add the sensor board, and so you can keep stacking boards on top of each other. And that's why with some projects, if you may look at online, they look like obnoxiously big, and the idea is you keep stacking all these shields on top of each other in order to get a device that you actually want to use. But showing you this, now you will understand a little bit more why Arduinos are usually called prototyping boards. And the reason is because you put all these shields together. Imagine you put 5 shields on top of each other. You know, you put a GPS shield, you put a Wi-Fi shield, and you put this shield and that shield and the other shield, and you get this big, nasty, ugly stack. And you look at it, and it proves what you want it to do. It proves that it can do everything that you need, but it's big and bulky and heavy, and nobody actually wants to buy something that looks like that. So what you do is once you make sure that the product does what you need, you get it verified by the customer, then you can go back and basically design the electronic device with only the components that you actually need. So that's why these shields are valuable, and now you can start to understand why they talk about Arduinos being prototyping boards, and why sometimes you're not necessarily going to want to use the finished product that you design just with the Arduino devices as what you're actually going to be selling to the customer. If you go over and we take a look on the computer, we can see all the different types of shields they have. So again, like they have Adafruit motor stepper servo shields. They have RFID NFC shields. They have wave shields. Let's see, data logging. So again, if you want to be able to track data, so let's say you put a GPS shield on to say what the location of the Arduino is, and then you can then write that data onto something like an SD card. They have the GPS shield, like I showed before. They have LCD shields. They have just all kinds of shields. And so that's one of the things that if you're going to be designing for the Arduino board, not only do you have to find the correct board that you're going to use, but you also need to go through, see what shields you're going to need, and then see what shields will connect to what Arduino boards and verify that they will connect together. But this is what we're talking about, shields, and this is why they're so cool, because they add all of this kind of different functionality to the Arduino. Now, if you're looking at the shields, one of the problems that you're going to see if you're thinking about creating any kind of IoT devices is that obviously the shields are connected directly to the Arduino board itself. So if you're thinking about creating some kind of little autonomous vehicle, or if you're thinking about creating something where there are going to be sensors in locations that are farther away from the Arduino board itself, you may be thinking, how can I get data to the Arduino board? Or how can I use the data from the Arduino board in something that's not directly connected so closely to the Arduino board itself? And that's where you get the modules or sensors that you can connect to the Arduino board simply using wires. So this is a proximity sensor here. So this is actually used in order to create little autonomous vehicles. And if you'll notice at the bottom of it, it simply has prongs that you can connect electronic wires to. So you can have the Arduino board sitting here in the vehicle, and then you can have wires that then run out to this proximity sensor, and then the vehicle will drive around, and whenever it gets too close to an object, it'll then stop, and then depending on the code, it then will move in whatever direction you want. So you could put numerous proximity sensors onto your Arduino project, or you could put temperature sensors. You could put all kinds of different sensors on there. Beyond that, you also have modules that you can add to your Arduino project. So if you look at this, so this is a motor and servo shield that connects directly to the Arduino board itself. So this connects directly onto the Arduino board, like so, and then you connect the wires off onto the motors or servos. But the question is what if you want to put the Arduino board in one location and then be able to control the motors or servos from a different location? And so what you do is you connect the motors or servos to this motor server module, and this will go in one location on your autonomous vehicle, and then you can put the Arduino board in another location on your autonomous vehicle, and then simply run cables from the Arduino board down to this module. So modules add functionality to your Arduino device, but they do it in such a way where all you have to do is you have to just run cables or little wires to the devices. They don't have to be connected directly to them. Again, when we start looking at sensors and such, they have just a ton of different sensors out there, everything from photovoltaic sensors to analog light sensors, color sensors, just about every different type of sensor that you can think of. The other thing to be thinking about too whenever you're dealing with these sensors or modules is that these can be used with different types of computer devices. So whenever you're dealing with an Arduino shield will more or less only connect to Arduino boards. The cool part with these sensors sensors is these are the types of sensors that you could actually connect these to something like a Raspberry Pi or some other type of computerized device, because essentially all they do is based on the signals that come in, they will trigger a response, or they will send the signals back to whatever board or computer device that you have. So that's one of the things. If you're going out there and you're playing with a lot of different IoT devices, let's say you're going out there playing with Raspberry Pi, and you're playing with the Arduino, and you're playing with the Beagle board, and you're playing with a number of different things, you may think about if there's an option for either a shield or a module or sensor, you may go with that module instead, because you could use that module for the Raspberry Pi or for the Arduino or for different devices, and so you can swap them back and forth. So that's is what we're talking about with the modules and the sensors. So now that we've talked about the shields and the modules for the Arduino, we need to talk about the standard electronic components that you're going to be using in order to create your Arduino projects. So what we're talking about with this is all of those basic things that you'll need to make an electronic project work. So things such as LED lights, right? So let's say if a certain condition is met, you want a green LED to be lit up. Or if a condition is not met, you want a red LED to light up. So let's say you're doing some kind of Arduino project in order to try to cool down a server room. So if the temperature goes above 90 degrees, you want the fan to kick on. But not only do you want the fan to kick on, you also want some kind of display to tell you whether the temperature in the room is below 90 degrees or above 90 degrees. So you may create the project, and so if the temperature is below 90 degrees, the light will be green to say the temperature is where it's supposed to be, and if the temperature gets above 90 degrees, it will be red. Now, one of the cool things why you use something like a breadboard is a breadboard allows you to create electronic projects without having to solder. So basically what you're able to do is you're able to just simply slide the components into the breadboard as such, and then be able to wire up your project to see if your project is doing what it's supposed to do. So make sure you're using the right resistors, make sure you're using the right capacitors, right? Making sure the negative is going to the negative, the positive, doing all of that kind of thing before you whip out the soldering iron and actually have to solder everything. Now, soldering is not hard, it's not complicated, but when you're experimenting, when you're playing around, you don't necessarily want to have to heat up the soldering iron every time you want to swap out something like an LED. So whenever you're dealing with the Arduino projects, you're going to have a breadboard like this in order to connect all of your electronic components. And then in here, you're going to be able to connect things like resistors. You're going to be able to connect things such as capacitors for your devices, LEDs, as I showed you. Beyond that, into the breadboards, you're also going to be able to connect servo motors. So servo motors are electric motors that are very precise, and you can tell them what position to go to. So a normal electric motor just spins around and around and around. So you can tell it to go forward, you can tell it to go back, and you can tell it what speed to go to, but then it just whips around. With a servo motor, you can tell it to go to a specific position. So this is a 180-degree servo motor. So you can say, I want you to go to 0, and it'll go to 0, or I want you to go to 180, it'll go to 180, or I want you to go to 90 degrees. So it will go to the specific place that you tell it. So you can plug servo motors in. As I just talked about, you can plug in electric motors. So if you want to use this in order to power a car, so if a car is going to be driving. So the difference between a servo motor and electric motor is this would be used for actually moving your little electric vehicle. This would be used for steering the electric vehicle. So if the vehicle is driving and you want it to turn left, you could use a servo motor basically in order to steer it left or to steer it right. So these are different things here. Beyond that, you also have things like LCD screens that you can connect to your Arduino project in order to show you specific things. So let's say if we were doing that temperature sensor Arduino project, this could tell you exactly what temperature is. If it's 90 degrees or it's 80 degrees or something like that, you can actually have this be able to give you a human readable readout, that type of thing. So these are the types of electronics components that you'll be using for your Arduino project, and just things that you need to be thinking about with what you're going to be building. So the final tool that we're going to need for Arduino projects, after we have the Arduino, after we have the shields, after we have the module, after we have the electronic components, Now we need to tell the Arduino what the hell it's supposed to do, and for that we use the standard Arduino IDE. So basically you're able to download an IDE that allows you to build little applications, scripts for your Arduino from arduino.cc. They have IDEs for Linux, Windows, and for Mac, and once you download that, then you can start writing your code and being able to upload it to your little Arduino. So if we go over and we take a look, this is what the Arduino IDE looks like, and this is what a little bit of code looks like here. I will explain all of this going into the future. We won't deal with it right now. But basically, just so you understand, with Arduino, they're essentially using C for the code, and all you do is within the IDE, you write out all the code, and then there's a little arrow button up at the top, and you connect the Arduino to a USB cable to your computer. You hit the arrow button, and then that will upload the code to your Arduino. If everything goes well, it'll just go up there, and if there's any failures, basically the IDE will kick back with whatever line the error is on, and you can go see. And basically, for me, most of the time, my biggest problem is I always forget the damn semicolons. But it'll tell you that. So that's the nice part with this is when you're uploading it to the Arduino, if there are problems with the code, it will fail out. Well, if there's syntax problems with the code, it will fail out before you upload it. So that's the good thing. You don't have to worry about your Arduino failing because you forgot to put a semicolon somewhere. Though if you did totally hash up, if you correctly wrote bad code, this obviously isn't going to help you out. But basically, this is what it looks like. And in a different class, we'll get more into how you actually code for the Arduino. So if you've seen all this and you're really excited about the Arduino and you're trying to figure out how you can learn more about building Arduino projects, besides, of course, watching my videos, the good thing is that there is a lot of material out there that will teach you how to build Arduino projects. What I would honestly recommend is the starter kit from Arduino itself. If you go to arduino.cc, they will have the official Arduino starter kit. For about $90, this kit comes with the Arduino board, it comes with a basic electronic components, and it comes with a very easy to understand book that will walk you through 15 different projects for how to build things with the Arduino. What I like about this is I actually own this particular thing, and what's good about it is it's very easy to understand. One of the problems you run into, especially with things like Arduino projects, is that people will expect a level of experience you may not have, even if you are a technology professional. And so a lot of times you don't know if you're doing something wrong or if you just don't understand what you're doing, that type of thing. What's nice with this particular kit is it walks you through everything. It has lots of different simple projects for you to do that are very specific. So the first, one of the first projects you'll do is you'll be able to create a little Arduino project that will show you what the temperature is. And then a different project will allow you to control electric motors. And a different project will allow you to control servo motors. And a different project will allow you to control LEDs. And so it allows you to focus on very specific components of the Arduino so that you really understand how those specific things work, and then you can have a better idea of how to build bigger projects. Beyond that, there are books such as Sam's in 24 Hours. So this is an Arduino programming book, and you can go through here and you can learn everything you need in order to code the Arduino. Why I would say though that you should start with the starter kit first is that this comes with all of these different electronic components that you may need. Again, that's one of the things. A lot of people think things like starter kits is that's only for kids. I'm a real technology person. I would never use a starter kit. But the thing is it comes with all the little resistors. Are you sure? Are you sure which resistor you're going to need? Are you going to need this resistor? Or are you going to need this resistor, right? Simply buying a starter kit, you get all the different little resistors, and then you can figure out, and you can go from there. The thing like with the Arduino, the programming book, this is actually a good book to read to learn how to program for the Arduino, but it only tells you how to program for the Arduino. Obviously, it doesn't have any of the different components. So these are some of the things that I would think about. Once you understand a little bit about how the Arduino works, you can then go onto Google, and simply you can Google any type of project you want to do with the Arduino, and there will be some kind of instruction set that will show you exactly how you need to wire things up and be able to write the code. So once you do understand how the Arduino works, then doing follow-on projects gets a little bit easy. I would say to start with a starter kit though, because as I've been learning about the Arduino, one of the things you do find is that the quality of things like instructional material really, there's some good stuff out there and some really horrible stuff out there. And so you don't want to get caught up buying some kind of starter kit that doesn't come with instructions. Like literally. I have a piece of crap little Arduino, for this. I have, it's literally it's supposed to be a vehicle kit. It's supposed to be a vehicle kit good for all ages. Literally doesn't even come with instructions. Not only does it not come with instructions, doesn't even come with all the wiring and stuff that you need in order to make the project work. And yet it is literally described on the package as good for all ages, or good for all ages and skill levels. And you sit there, you're like, but you don't, it doesn't even have all the components, much less it doesn't even have the instructions for how to do things. So that's where I would say I really would start out with the Arduino starter kit, and then from there go and find different projects and things that you can do, and kind of expand your knowledge from there. Now the final question you'll have is, okay, Eli, this sounds cool. Arduino sound cool, Shield sound cool, electronics sound cool. Yeah, okay, I'll buy that starter kit. But where do you buy all the extra stuff? Where do you go out and buy shields? Where do you buy electronic components? Where do you buy all these things that you can build your projects? Well, if you're lucky enough like me, you may have a micro center in your area. So I started out buying these little things from the local micro center. I was very happy that they had Arduino things. But now that I've been going along and I need more complicated things, what I have found is that there's a couple of places online that are really great for buying not just the Arduino components, but all the other kind of electronic stuff too. The one that I would really recommend, that I would say that you should take a look at, is Adafruit, Adafruit. If you go to Adafruit, you'll see that not only do they have Arduino stuff, so 183 Arduino things. They also have Raspberry Pi. They have accessories, Android things, batteries, BeagleBone, books, breakout boards, cables, components. So what I like about Adafruit is it basically has everything that 99% of the people will need. All kinds of cool stuff you can go here and take a look at. And then beyond Adafruit, the other online destination that's popular with people is SparkFun. So if you come here to SparkFun, you'll also notice they've got Arduino and cables and components and LCDs, robotics, and all kinds of different things. So if you're looking to start building Arduino projects, I would really say that probably Adafruit and SparkFun will get you 99.9999% of any of the products that you will probably need for the projects that you're doing. So that's all there is to the introduction to Arduino. Now I know some people are going to be saying, but Eli, you haven't shown us how to code, you haven't shown us how to use breadboards, you haven't really shown us anything. But as I talk about with my classes, one of the biggest problems whenever you dive into a technology is simply understanding what all the little bits and components are. A lot of people, they try to dive in, and if you don't know the difference between a shield and a module, or the difference between the different Arduino boards, you can dive in and become confused very quickly. And then when people get very confused, then they get frustrated. And when they get frustrated, then they quit. And then, well, that's kind of worthless. So basically, starting out, all I'm trying to do here is show you the basic little bits that are required in order to create Arduino projects. And then in future classes, we will get more into the specifics. So we will have a specific class that will talk about all of the different functionality of an Arduino board. We'll talk about the analog. We'll talk about the digital inputs and outputs. We'll talk about powering the Arduino board, so on and so forth, so you feel much more comfortable with the Arduino board itself. We'll talk about the shields. We'll get more specific into what different shields do, show you some of the coding snippets and that kind of thing in order to control the shields. We'll obviously show you the IDE, how to add libraries, how to write the code for the Arduino boards, but we will do those in specific individual videos. So now, once that you have this basis, then you can go to those additional classes and you can really understand what's going on. Overall, I'm very happy. I like these Arduinos. I think these little Arduino projects are very fun and very interesting. It's very cool how you can use little computer devices in order to make physical actions happen and all that kind of stuff. And what I have found is, honestly, the Arduino really is pretty darn easy to use. Basically, as far as coding and all that's concerned, you know, if you give yourself, I think if you give yourself 2 weeks, I don't know, if you give yourself somewhere between 20 to 40 hours of actually focusing on the Arduino, I think you can get very comfortable being able to build projects and do kind of some of the fancy cool stuff that you see other people doing. So anyways, that's about it. This is the class, the Introduction to Arduino. I enjoyed doing this video as always, and look forward to seeing you at the next one.